this lesson, we're looking at some examples of inverse trigonometric function derivatives. So I'll remind you here at the top of the three rules: the derivative of arcsine, arccos, and arctan, and we'll apply them through the following set of scenarios. Okay, so the first one's very simple. You can see it's in the form arcsine x on a, where a is equal to 3. Using our derivative, where d dx of sine to the arcsine x on 3 is equal to 1 over square root of a squared subtract x squared. The derivative of arcsine x on 3 will simply be 1 on square root of 3 squared take x squared, or 1 on the square root of 9 take x squared. Alright, so nice and simple. It's all about using this standard rule where a is equal to 3. Okay, so when we look at, in the second example, we're looking to find the derivative of y is equal to arccos 4x. Now we know the rule. We know that d dx of arccos of x on a is equal to negative 1 over square root of a squared take x squared. So if we look at this scenario, we can see that it's going to be a chain rule. So that means we're going to let u equal 4x, and obviously a will have to be 1. And therefore, our y in terms of u will be arccos u on 1. So when we find this using the chain rule, dy dx, du dx multiplied by dy du, du dx will be 4, and dy du will be negative 1 over the square root of a squared, which is 1 squared, subtract u squared, which means we end up with negative 4 on square root of 1 take u squared. And when we put u squared back in, we've got negative 4 on square root of 1 take 4x all squared, which is 16x squared. So there we have it. There's our derivative, negative 4 over square root of 1 take 16x squared. Okay, so when we get to the next example, we're going to see that it's a chain rule again. So we've got 2/3 this time. So we know that d dx of arctan x on a is equal to a over a squared plus x squared. So in this scenario, we're going to let u equal 2/3 x, and therefore y will be equal to arctan of u on 1. And so this should be the easiest scenario. So dy dx will be du dx multiplied by dy du. Du dx is simply 2/3, and dy du will be 1 over 1 squared plus u squared. So we've got 2 over 3 plus 3u squared. Now since u is 2/3 x, we've got 2 over 3 plus 3 lots of 2 on the 3x all squared will give us 2 over 3 plus 4x squared on 3. If we get a common denominator on the bottom, we've got 2 over 9 plus 4x squared all on 3. And if we're dividing by a fraction, we're multiplying by the reciprocal, so therefore we end up with 6 over 9 plus 4x squared. Alright, so there's our derivative of arctan 2x on 3. And when we look at our final example now, we're looking to find the derivative of y is equal to arcsine x squared take 1. So we're in a similar scenario here. We know that the derivative of arcsine of x on a is equal to 1 over the square root of a squared take x squared. So in this scenario, we want to let u equal x squared take 1. We want a to be equivalent to 1. We're looking at arc sine of u on 1. So to find this derivative, dy dx is equal to du dx multiplied by dy du. Du dx is 2x, and dy du will be 1 over square root of 1 squared subtract u squared. So we've got 2x on square root of 1 take u squared. Now, u is x squared take 1. So we've got square root of 1 take x squared take 1 all squared. When we expand that, we've got 1 take away. Now x squared squared is x to the power of 4. 2 times x squared times negative 1 is negative 2x squared. And negative 1 squared is plus 1. So we've got 2x over square root of 1 take x to the power of 4 plus 2x squared take 1. And we're left with 2x over the square root of 2x squared take x to the power of 4. And there it is as our derivative, dy dx. Okay, so you can see that with these derivatives, if it becomes a chain rule, you have to be a little bit careful. In its simplest form, these integrals are nice and straightforward. It's just a matter of identifying the a value and substituting in. Right? Hopefully that makes sense. You'll have a chance to practice these and become fluent. Thank you for listening.